Alright guys, we're going to keep going with circles. Now before we continue going with circles, for a little while now, we are going to have to finish up some of our circle terms. So we're going to do the ones that have to do with 15.3 today, since that's what video this is. So you should have had some extra blank note cards, those of you at home. I mentioned this in the video, but you might go grab yourself a couple note cards. Today we only need 3 more note cards. Tomorrow we'll need about 4 more. I think. Yes. 4 more. Okay, so today in your note cards here, I've got 3 new terms. Okay, I'm going to show you these terms. I'm going to show you the front and back of the note card. You're going to want to pause the video. The definitions are already on these note cards, so you don't have to go look them up, but you are going to need to copy them. Now, I'm only going to show them to you for a short amount of time. Definitely not long enough to copy them, which means you're going to want to pause it. Okay, so these are the 3 new terms we're going to talk about, and then they're going to go in your circle terms pocket. The first one is a circumscribed angle. There you go. You'll need to draw the picture. A circumscribed angle is an angle formed by 2 rays from a common endpoint that are tangent to a circle. We're going to talk about the word tangent as well, but circumscribed angle is the first one. So you're going to want to pause that in case you haven't gotten it yet. The other side, of course, is circumscribed angle, because you are going to need to know these. Okay, so that's one of the 3. I'm going to put this in my pocket now. Go back and pause it in case you need to for the definition. Okay, let's talk about tangent now. Probably should have started there, but I will. Tangent is a line in the same plane as a circle that intersects the circle in exactly 1 point. So it touches exactly 1 point. Yes, this is different than the actual trig ratio tangent. They are kind of related in that the graph of a tangent only touches, and you'll learn all that later. But there is a small connection, but not a big one. Okay. Tangent on the other side. So you pause that video to get that one. And the last is point of tangency, which is literally the point where a tangent and a circle intersect. So point P is the tangent point of tangency. Okay, so pause the video if you need to. I'm going to flip it over so you can see I've got point of tangency on the other side. Okay, so those are the 3 new terms you need for today's lesson. I'm putting those back in my envelope. In circle terms, you should still have 4 blank note cards. All right, today we are working on page 129, and the title for 129 is 15.3 Tangents and Circumscribed Angles, which is why we needed those vocabulary words. So the left one is blank, and it is on 129, okay? 129, so let's go label 129. 15.3 Tangents and circumscribed angles. That's on 129. I'm going to go ahead and show you where to glue it, and then we're going to get started. So you have this handout attached. Go ahead and fold it in half. Looks like this. Just like before, we are going to cut it. Tangent radius theorem, converse of the tangent radius theorem, and circumscribed angle theorem. I'm going to go ahead and cut that. And the lines finally line up this time. I don't know if they line up on anything else, but they do this time. I'm going to glue it in on 129, and then we're going to get started on actually doing the problems. Okay. All right, let's get started on the first one, the tangent radius theorem.
All right, so given that theorem there, that we have a right angle here every time we have that line in the radius, we're going to look and do a couple of these problems. So we do actually, it says refer to the figure for problems 1 through 4. AB is tangent to C. What does that mean is true right here? CBA is 90 degrees. I'm going to draw that little box in there. That's 90 degrees. Okay. At point B. And AD is tangent at point, this should say at point D. So this is tangent here. What does that mean? I can find out what angle C is, you're right. But this is also 90 degrees. Alright, so here's what I need to figure out. I'm going to zoom in on the picture instead of the questions. Number 1 says we are supposed to find the measure of angle ABC. 90 degrees because of the tangent radius theorem. So ABC is 90 degrees. Okay, we're going to look at number 2. This is the one that you guys just said, hey, we could find this one, DCB. DCB, I'm going to put a little marker so you know where it is. DCB is right here. How am I going to find that? 90 plus 90 is 180. Okay. Then you add 40. Here's what he's doing. He's saying, hey, we have a quadrilateral right here, right? And how many degrees are in a quadrilateral? 360. So what is 180 plus 40? And there's 360 degrees in a quadrilateral. So we're going to subtract and get. So the measure of DCB is 140 degrees. Yes, you could also make it into 2 triangles. No idea. That like something didn't get cut off right or something. That's just the extra little piece that it shouldn't be there. Okay, now we know this is 140 right there. And we now need to find, number 3 says find BDA. This angle right here. We're going to learn in a minute that this actually is an isosceles triangle. So we're going to assume it is at the moment. But in the next theorem, we will actually learn it is. So if this is 40, how do I find out what each of these pieces are then? Okay, 180 minus 40, which is 140. Divide that by 2. 70. Okay. So this is 70. Because you had an isosceles triangle. Last angle there. CDB, right here. How do you know that's 20? That one is 20. You could also have done the same thing. Since this is the radius, these two are congruent. 180 minus 140 is 40. Divided by half is 20. Not divided by half. Divided by 2 is 20. Okay, so there are all those pieces. I want you guys to work on 5 through 8. Before you do, though, 5 through 8 is talking about the converse of the tangent radius theorem. Well, what is a converse again? The opposite. So now it's saying, hey, if the line is perpendicular to the radius, then it's a tangent to that circle. The problems are pretty much the same, though. So work 5 through 8 with that measure given, and we'll go over those in a minute. Alright, 5 through 8. This is almost, other than the perpendicular segment. Most of it is a review of stuff we've done in the past, which you may have forgotten over the weekend. But the measure of BCD here, can we find that to start with? Or do we probably need to find something else first? Let's move on and try 6 next. The measure of angle CDA, what is that? That's 90 degrees. Okay, so that will definitely help us find number 5, which we'll do since it's a quadrilateral. Okay. Okay, can we find BED yet? BED? I think we need to find something else first. That one probably threw you for a loop for a minute, and you'll see why. Alright, how about DBA? Can I find that one yet? I can. Yes, I can. How can I find that one? Okay. Let me see. It was I can't read. DBA. This one right here. Since it's isosceles, we'll get the theorem for why it's isosceles in a minute. 180 minus 32, what's that? And then we divide it by 2 and get, so BDA is 74 degrees. Alright, now let's do the other two. Let's do BCD first. So angle BCD, I know this is 32, I know these two are 90. How many degrees are there in a quadrilateral? Okay, so 90 plus 90 is 180, plus 32. What's 180? Yep. You're right, I don't have to do 180 plus 32. Why? Okay, we can do that instead. It's the same amount of work, the same process. So he's saying instead of doing that, we could find this angle right here, right? What is 90 minus 74? He's saying then I've got a triangle. 16 and 16 is 32. And subtract that from 180. It's what? 148 degrees. That is BCD. Number 5 is 148 degrees. This is the sad thing about circles. There's a whole lot of stuff to remember. Alright, now, I want you to take a highlighter out. I don't care what color, you just need one. Because this next one is remembering a lot of stuff. We need to find BED. What is BED? It's an intercepted arc. Not intercepted arc. An inscribed angle. To find the measure of that inscribed angle, we need to know the measure of its intercepted arc. Do we know that? We do. Not 2 times c. The central angle and the arc are what? The central angle and this arc are the same. This arc is 148 degrees. What does that mean about this inscribed angle? It's half. What is BED? 74 degrees. Possibly, yes. Yes, we're going to see that in a minute. Alright, so in case you did not get those, here are all 4 of those solutions. 148, 74, 90, and 74. So we just realized that a circumscribed angle of a circle and its associated central angle are supplementary. We're going to draw that in. So draw this in and put A, B, C, and D. So what this is saying is that the measure of angle BCD plus the measure of angle BAD is equal to 180. That's what the theorem actually says. That helps, we know that these are 90 already because of the last theorem. Alright, but what else did we just figure out as well? Yeah, we just figured out that also AB is congruent to AD. We already knew that these were 90. What else did we already know? BC is congruent to CD just because they're radii. You know what shape this is? It's a kite. Yep. Alright. We're going to do some examples with that. Okay. So once you write that on the slide over, we're going to do some examples. 9 and 10. Okay, number 9. First we have to find x. What is true about angle P compared to angle Q? So 2x minus 7 plus x plus 1 equals 180. There's not a whole lot of room here, I know that, and I'm sorry. Alright, so combine like terms and you get 3x minus 6 equals 180. And then what? Add 6. So 3x equals, and then what do you do? So x equals, it's what? (62). That is x, not an angle, so do not put degrees. How do you find NQM? Substitute. X plus 1 becomes 62 plus 1. What is 62 plus 1? 63 degrees. Alright, how about P and Q? 90, because it's a tangent and a radius. Okay, and how about NPM? You can either plug it in, double it, subtract 7, or you can do 180 minus 63, which is what? 117. Okay, there's all the work for number 9. I want you guys to do number 10. Okay. What did you guys set up on number 10? Plus 2x minus 2 equals 180. Okay. 8x minus 12 equals 180. 8x equals 192. Divide by 8 and x is 24. Alright, then you plug back in. QMP. You didn't have to plug in on that one. Okay. MQN. Okay, so you do 2 times 24, which is 48, and you subtract 2 and you got 46. Okay. How about NPM? You can either subtract 46 from 180, or plug in and do 6 times 24 minus 10. Either way, you get 134.